Hi, namaste everyone. This is the lecture 4 on proton magnetic resonance spectroscopy. In earlier slides, we have discussed the principal, chemical shift, equivalent and non-equivalent protons in lecture 3. In lecture 4, let us discuss the further contents of this topic. Those are spin splitting and interpretation of HMR spectra of different compounds. So, if you go for the splitting of signals, what do you mean by splitting of signals? Means the phenomenon of splitting of a signal into a group of peaks is called a spin splitting. This occurs due to the spin coupling. The spin coupling occurs between the neighboring non-equivalent protons. This is related to the possible combination of spin orientations of neighboring protons. The magnitude of coupling decreases as the number of bonds between the coupled nuclei increases. So, what is this spin coupling? How the intensities of the multiplets will be there means it's according to the binomial expression, that is if n equal to 1, n equal to 1 means neighboring proton. If number of neighboring protons are 1, then 1 plus x to the power of n. N place, in the n place if you take 1, you will get 1 plus x. The intensities of the peak will be in the ratio of 1 plus x. If n equal to 2, then you will get the relative intensities of the peak, that is a triplet, and the ratios 1:2:1. If neighboring protons equal to 3, then you will get 4 peaks, that is a quartet, and the intensities are 1:3:1 like this. And you can see this is a Pascal triangle. In this Pascal triangle you can see the intensities of the peaks. If one signal is present, it is a singlet. If a signal splits into 2 peaks, it is called a doublet in the ratio of 1:1. If the signal splits into 3, it is called triplet in the ratio 1:2:1. If the signal splits into 4 peaks, it is called quartet and the ratio 1:3:1 like this. So, if you see this, how this splitting takes place according to the which rule? So, according to the n plus 1 rule, the splitting takes place. Here the carbon is having 1 proton. The signal for this proton is a singlet. Okay. If you see this carbon is having a single proton, and adjacent to and neighboring protons, how many neighboring protons are there? Only 1. So, n equal to 1. 1 plus 1, 2. So, you will get a doublet in the ratio of 1:1. If this carbon is having 1 proton and neighboring, how many protons are there? 1 and 2. So, this proton spin is coupled with neighboring 2 protons spins. So, neighboring protons, how many are there? 2. So, according to the n plus 1 rule, 2 plus 1 equal to 3. So, the signal will splits into 3 peaks, that is a triplet in the ratio 1:2:1. So, here if you see, this carbon is having this proton. This proton is coupled with how many protons? 1, 2 and 3. How many adjacent protons are there? 3. So, 3 plus 1 you will get a quartet in the ratio of 1:3:3:1. So, this how, like this the coupling takes place in NMR spectroscopy. And if we see the mechanism and interaction, how this coupling interaction takes place, these nuclei here, this is the proton, is yellow colored carbon is having a proton. Now this proton is having the spin, that is plus off. When plus off spin nuclei couples with the adjacent proton, you will get a signal in the downfield region. Okay. If this brinjal color proton having the spin minus off, when the protons having the minus of spin couples with the adjacent protons, you will get the signal in the upfield region. Okay. Minus of spin when couples with the adjacent proton, you will get the signal in the upfield region. When plus of spin couples with the adjacent proton, you will get the signal in the downfield region. Means in a molecule, half of the molecule in a solution will have plus of spin and other half will have a minus of spin. Like this the interaction takes place. If you see some more examples here, if you see the spin arrangements, here you can see, if you take this yellow color proton, how many adjacent protons are there for this proton? 1. So according to n plus 1 rule, you will get 2, means that is a doublet. So one neighbor proton, so according to the n plus 1 you will get 2, that is a doublet. Here you can see the signal, here you can see the signal for this proton is a doublet. And if you see the signal for this proton, how many adjacent protons are there? 1. So n plus 1 equal to, so equal doublet. So the signal for this proton is a doublet. The signal for this proton is also a doublet. Okay, and some more example, if you see that here this proton, for this proton how many adjacent protons are there? 2. 2 neighbors. So n plus 1 means n place 2 plus 1 equal to 3. So this is the, you will get the triplet for this proton. So these are the methylene spins. Here in methylene how many protons are there? 1 and 2. 2 spins are there. So the possible spin combinations are, maybe all 2 spins are clockwise, anti-clockwise, or one is clockwise, anti-clockwise, the other is anti-clockwise and clockwise. These are the possible combinations. So 1 is to 2 is to 1. So the peak obtained here will be in the ratio of 1 is to 2 is to 1, that is a triplet. For if you see the peak for these protons, these 2 protons have the adjacent only 1 proton. So according 1 neighbor proton, so n plus 1, 1 plus 1 equal to 2, doublet. So these protons will give a doublet. These spins may be plus of or minus of. Like this the spin splitting takes place. And if you see some more example, that is here in brinjal color, here blue color, the here you have the protons, and how many adjacent protons are there? 3 protons. So according to n plus 1 rule, these protons signal will split into a quartet. 3 plus 1 you will get 4, that is a quartet in the ratio of 1 is to 3 is to 1. 1 is to 3 is to 1. So here if you see the signal for this, how you will calculate the signal for these protons? How many adjacent protons are there? 2. So 2 plus 1 you will get a 3, that is a triplet. So the signal for these protons is a triplet, that is 1 is to 2 is to 1. So like this the splitting takes place. And if you see the interpretation of a NMR spectra or PMR spectra, the number of signals in the spectrum tells us how many kinds of protons in different chemical environment are present, and the position of signal takes the electronic environment. Intensities of different signal tells about the relative number of protons of different kind. Splitting of signals tells about the environment of absorbing protons with respect to environments of neighboring protons. Okay, so let us see some molecules. First, if you go for the ethyl bromide. In ethyl bromide, how many types of protons are there? 2 types. Let us see the data for this. This molecule has 2 kinds of protons. For a kind of proton, that is CH3 protons, for these protons the signal splits to peaks according to the n plus 1 rule. So at neighboring protons how many are there? 2. 2 plus 1 you will get a triplet. So according to the n plus 1, 2 plus 1 equal to triplet, that is 1.6 delta upfill. For B kind of protons, that is CH2 protons, the signal splits into the according to the n plus 1 rule. So if you in neighboring 3 is there, so 3 plus 1 quartet at 3.4 delta downfill. If you see the diagram, it is clearly that CH3, CH2, Br. These CH3 means A type proton. Okay, this is the signal for the A type proton. This is the signal for the A type proton. Adjacent 2 plus 1, so 3. A protons are splits into a triplet, and B protons give the signal quartet. B protons give the quartet at 3.4 delta. So this is the spectrum of ethyl bromide. And if you go for the spectrum of acetaldehyde, here in acetaldehyde this molecule also has two kinds of protons, and for A kind of proton, that is CH3, the signal will splits according to the n plus 1 rule. So n plus 1 rule, adjacent you have 1 proton, 1 plus 1 you will get a 2, that is a doublet at upfield. And for B type proton, that is aldehydic proton, adjacent protons are 3, so 3 plus 1 4, you will get a quartet. And here you can see, in this picture you can see doublet at delta 2.2, 3 hydrogens CH3, and a quartet at delta 9.8, 1 hydrogen, that is the aldehydic protons. Is it clear? So doublet here CH3, here this is the CH3 signal. CH3 signal, the adjacent protons are 1. So 1 plus 1, you will get a doublet for CH3 and quartet for CH. Why quartet for CH? Adjacent protons are 3. So 3 plus 1, you will get 4. So quartet for an aldehydic proton at delta 9.8 ppm. This is the interpretation of acetaldehyde NMR spectra. And if you go for the other compound, that is 1,1,2 tribromoethane, this molecule has two kinds of protons. The signal for B kind of proton splits as n plus 1, that is 1 plus 1 equal to 2 doublet. The signal for A kind of proton splits as n plus 1, that is 2 plus 1 equal to 3, that is a triplet downfield. Here it is clear that 1.1,12 tribromoethane, here A protons, A has how many? This A means CH. The signal for these comes according to the n plus 1 rule. How many adjacent protons are there? 2 plus 2 are there. 2 plus 1, triplet. So here you can see A protons at the triplet at downfield, and B protons. For B proton, the signal, how many adjacent protons are there? 1. 1 plus 1, so you will get a doublet at upfield. And if you move on for the fourth compound, that is ethyl acetate, it has 3 kinds of protons. The signal for A kind of proton splits into 3 peaks, and signal for B kind of proton splits into 4 peaks. And here signal for C, it splits into the quartet. So in ethyl acetate, here if you see the clearly, CH3, C double bond O, CH2, CH3. If we take this A, how many adjacent protons are there? 2. 2 plus 1, triplet. So this CH3 gives triplet. This is the triplet peak. And if we go for the B, that is CH3, adjacent protons, there are no adjacent protons, only C double bond O is there. There is no adjacent protons. So this CH3B gives a synlet. There is no coupling takes place because there are absent of adjacent protons for these B type protons. If you go for the C type of protons, how many adjacent protons are there? 3. 3 plus 1, it gives a quartet. So C protons gives a quartet at delta 4.1. So this is about the ethyl acetate. And if you go for the acetophenone, the signal for methyl proton appears as a synlet. Here you will have a CH3 acetophenone, C6H5, C double bond CH3, CH3. These, if we take the CH3 protons, there are no adjacent protons. So CH3 will give a synlet. CH3 will give a synlet. This is the synlet. And Here you will have three different type of protons and the benzene, two orthoprotons, two metaprotons and one paraprotons. So they will give the multiplet. Two metaprotons give multiplet at 7.3 delta and one paraproton gives multiplet at 7.6 delta, and two orthoprotons gives multiplet at 7.9 delta ppm. This is a spectrum of acetophenone. These 5 compounds are very important, and thank you for watching video.